IP broadcast control, or more specifically about NMOS. So I know that the previous presenter had mentioned NMOS on a few occasions, and the fact that perhaps it is not a perfect implementation. But I think it is still very, very important and a critical part of an IP deployment or a successful IP solution. So I think at this point in time, it would still be helpful for my colleague KK to introduce to everybody the concepts around NMOS and the role it plays and why it is important in an IP environment. So when we start to talk about IP, we need to really talk about the why. Why IP? So as we all know, broadcast is changing, and broadcasters need to adapt to traditional as well as future revenue models, and customers or viewers are now more than before dictating how they watch content, when they watch content, and where they watch content. So because of that, technologies like COTS, software-based solutions, virtualization have become more and more important. And because of that, it is also more logical, makes perfect sense to then transition from SDI to a more generic IP environment, especially when we start talking about technologies like UHD, like HDR, and like high frame rates. So what are some of the benefits of IP in that context? Firstly, it is a lot more flexible and a lot more scalable. And when we start looking at specifically SMPTE 2110, it is also format agnostic. So meaning that it theoretically should be easy to interoperate between different solutions and different vendors. One of the lessons that we learned is that that isn't always the case, and I'll talk about that a little bit later on. So with the implementation of IP, at the end of the day, you're able to improve upon your manpower, your resourcing. You're able to go on air faster, to stand up a new studio faster, and ultimately to lower the total cost of ownership. So with this particular IP or UHD IP studio deployment, we had deployed 4 of our ingest and playout servers in both UHD and HD. We call our servers Venice. We also had a shared storage system with which all content can be shared and easily accessible between all the various servers, as well as to the rest of the ecosystem. So what were some of the technologies or formats that we had to adhere to? First one obviously was SMPTE 2110. Another one was SMPTE 2022-7 for redundancy, for seamless playback. And then there was the entire NMOS infrastructure for automatic discovery and for better interoperability. We also had to work with APIs for VDCP over IP. We had to work with channel audio routing and various video codecs or wrappers. For example, OP1A, XADC Intra class 300 UHD, as well as OP Atom, which was the editing format. All of that with SNMP within a 100 gig, 10 gig, and 1 gig network infrastructure. We weren't alone, obviously. In this whole IP deployment, there was a lot of interoperability with other vendors and other solutions. So there was automation, there was Aveco to control the ingest and the playing out of content. There was the Sony Live System Manager, which functioned like a switcher or a router for IP streams. We had to work with a Chinese solution provider called Gefei for system monitoring. There was also PTP, which was like a time sync for IP. We had to integrate with Sony IP cameras and even an EBS playout server for the occasional slow-mo playback. So they're within a Mellanox switch environment in 100 gig, 10 gig, and 1 gig. And all of that going through a Diam gateway, which was then connected to a Diam man to make the ingested content available to the larger post-production environment and to get it back into the playout environment. So it was a relatively comprehensive and complex environment with multiple vendors working together. The challenges that we encountered, I think, were manifold, But in a nutshell, I think they fell into two categories. One was in terms of networking and network planning, and the other one was around integration with multiple vendors. Because what we found was that although all these solutions were all SMPTE 2110 compliant, there was enough variation within the SMPTE 2110 spec to occasionally cause issues with interoperability. So I'm not going to run through all of these. I had gone through this in a similar ABU, I think it was a DBS seminar about a month ago, so I think these slides will be made available, so you can certainly read through them and feel free to contact my colleagues or me should you have any further questions. On the topic of network planning and its importance, one of the initial issues that we encountered was around subnets. So all of the rodent trust solutions were placed on a particular subnet, which then didn't work because we found that the NMOS and the PGP signals were not coming through directly. So all of our solutions then had to be connected to a core switch. On the topic of networking, another aspect of networking that we had to address and be very mindful of was around multicast. So in the switch, we needed some capability to block certain multicasts in order to not create that bottleneck. So networking was of key importance. The other element that we very quickly learned was around interoperability. One good example was with the Sony Live System Manager, or the LSM, which, as I mentioned, served as a router for the IP signals. All the solutions were SMPTE 2110 compliant, but the Sony LSM was configured via a manual or via a messaging schema, whereas other solutions were configured via FTP. So even with that small differentiation caused some initial issues. Another example was around the Lao multi-viewer, for example. So we were seeing pictures flickering on the multi-viewer, and after much troubleshooting, we realized that it actually had to do with packet sizing. So there was a packet size mismatch. So the packet sizing that the Lao multi-viewer was expecting and the packet sizing that our servers were sending out were different. But both of them were within the SMPTE 2110 spec. So that was the adjustment, or another example of some adjustments that had to be made around interoperability. When it came to monitoring, we also had to be very mindful of latency, because there is a very, very narrow latency range or latency threshold beyond which signals can no longer be detected audio-wise. Okay, so just to go back to our solution, Venice S, which is our ingest and playout server, this is an extract of the user interface, and you can see that we can seamlessly toggle the system on the fly between HD, ingest and playout, or UHD, ingest and playout, without disrupting operations and certainly without having to restart the system. Another key requirement that the customer had was the interchangeability, or the very quick reconfiguration of our servers between SDI to IP or the other way around. So with our servers, all it took was the changing out of SFP pluses to change the system from an IP system to an SDI-based system, or vice versa. So certainly you did not have to invest additional money for additional hardware to make that change. So with that, I just wanted to give you a bit of an overview, right, of the recent IP UHD deployment that we successfully completed. But really, we wanted to devote more time in this seminar or this presentation to talk about NMOS, why it's important, what purpose does it serve, and really what are the underlying principles behind NMOS. So with that, I would like to hand it over to my colleague Ka Kyong, better known as KK, to run through some of the foundational principles behind NMOS.
Hi, good afternoon everyone. Thanks, Eugene. So, Sri, are you actually showing my screen now? Just to check.
Yes, right. Yeah. Please go ahead. Yeah.
Okay. So, I'm very fortunate, to be honest, to be actually involving in this 4K IP studio project, starting all the way from beginning designing, putting up a requirement, meeting with customers, different vendors, talking and discussing how we can run and implement this whole IP 4K UHD project. So, as everyone I think knows that we are all actually kind of like this thinking whether we should move up from SDI world to the 2110 world. In fact, as of today, I've met many other broadcasters and they are still thinking whether they should move on or maybe just stick with SDI and then go with 12G to meet the 4K or even 8K requirement. But just in case you want to move to 2110, to have a better understanding, and right, SDI to IP world, in terms of SIMT 2110, there will be different parameters needed to be addressed or take care of. So there will be audio, video, ancillary, and time, right? These are the parameters that need to be actually catered for to have a successful deployment. So in terms of the standard, as you can see, right, within SIMT 2110, there are system timing, which is 10, 20 is uncompressed video, 21 traffic shaping, 30 PCM audio, 40 and ancillary data, and of course most importantly 2022-7, which attack you in terms of seamless streaming. Okay. So in terms of how we stream, okay, the packets, it can be actually streamed across ports, different ports, and depending on the port requirement. So it can be a 10G port, 25G,
Yoshi?
100G.
Yoshi?
So,
Di ba? Tapos ko lang itong ano. Hindi, nagre-record kasi ako.
Some might use 10G, some might use 40G, and some might use even 100G.
30 minutes lang naman yun. Sige na, sige na.
It's a video server, a multi-video, or camera. And also, it really depends on the codec format. What are you actually sending? So we actually three types of how people will want to send FP on a port.
May labo sila rito eh.
Implementation can be actually a portion per port assignment. So meaning within that 10G or 100G, right? I'm actually sending 4 streams.
Sige. Magano, sige.
And at the same time, okay, I'm actually creating a redundancy port. You be sending port, okay, the original port. So this is actually text by the city and it include. The other approach actually thinking from 10G to 100G, it can be a 2-stream per port assignment. Okay, so